Good morning, students. Today we shall begin with a new lesson, that is lesson number 7, lenses, from Science Part 1. So children, let's begin. Lenses. In our everyday life, lenses play an important role. Some common examples where lenses used are P-hole, lens embedded in front of the door of your house. Loop, lens used by a watchmaker to see the extremely small parts of the watch clearly. It is also used in spectacles, camera, binoculars, microscope, etc. A lens is a transparent medium bound by two surfaces. The lens, which has two spherical surfaces which are puffed up outwards, is called a convex or double convex lens. This lens is thicker near the center as compared to the edges. The lens with both the surface spherical on inner side is called a concave or a double concave lens. This lens is thinner at the center as compared to the edges. Biconvex lens, plano-convex lens, convexo-concave lens, biconcave lens, plano-concave lens, concavo-convex lens. These are different types of lenses. Come, let us understand the refraction of light by one of these lenses briefly. A ray of light gets refracted twice while passing through a lens. Once while entering the lens and once while emerging from the lens. The direction of the ray changes because of these refraction. Now children, before moving ahead, we shall learn the terms related to lenses. Terms related to lenses. The cross section of convex and concave lenses are shown. The surface marked as 1 is a part of sphere 1 S1, while the surface 2 is a part of sphere S2. Center of curvature. The center of the sphere of which the surface of a lens is a part is called the center of curvature. Observe the figure, children. C1 and C2 are the center of curvature. Radius of curvature. The radius of the sphere of which the surface of a lens is a part is called the radius of curvature. Radii R1 and R2 are the radii of the curvature of the lenses. Principal axis. The imaginary line passing through the two centers of curvature of the lens is called the principal axis. Optical center. The central point of a lens on the principal axis through which the ray of light does not suffer deviation is called optical center. Ray P1Q1 and P2Q2 passing through O are going along a straight line. Thus, O is the optical center of the lens. Next is principal focus. When several rays of light parallel to principal axis are incident on a convex lens, after refraction, they converge to a point on the principal axis. This point on the principal axis is called the principal focus of the convex lens. Light rays parallel to the principal axis falling on a convex lens come together, that is, get focused at a point on the principal axis. So this type of lens is called a converging lens. F1 and F2 are principal foci of the convex lens. Now children, light rays parallel to the principal axis are incident on a concave lens. After refraction, they appear to diverge from a point on the principal axis. This point on the principal axis is called the principal focus of the concave lens. Light rays parallel to the principal axis falling on the concave lens go away from one another. That is, they diverge after refraction. So, this type of lenses are also called a divergent lens. Focal length. The distance between principal focus and optical center of the lens is the focal length. Understood, children? Now, after learning the terms related to the lenses, let us perform an activity to find the focal length of a convex lens. To determine the focal length of a convex lens. Activity. We need a convex lens, screen, meter scale, and a lens holder to perform this activity. Let us take a convex lens and place it on a lens holder. Select a distant object such as a tree. Place the convex lens in front of the tree. Now place the screen behind the lens. Move the screen towards or away from the lens until a well-defined image of tree is obtained on the screen. At this distance from the convex lens, we get a well-defined inverted image of the tree on the screen. Let us now measure the distance between the optical center of the lens and the image on the screen with the help of a meter scale. The distance is 20 centimeter. Now turn the lens so that the surface of the lens which was facing the tree will now face the screen. Let us again move the screen towards or away from the lens. At this distance from the convex lens, we get a well-defined image of the tree on the screen. Let us now measure the distance between the optical center and the image on the screen with the help of a meter scale. The distance is 20 centimeter. What do we notice? Yes, we noticed that the distance measured in both the ways is the same. It should be noted that instead of a screen, the lens can also be moved. However, the distance between the screen and the convex lens will not change. What is the distance between the lens and the screen called? Right, the image of the distance object nearly at the focus of the lens. Hence, the distance between the lens and the screen which we measured is the focal length of the lens. Generally, the focal length is half of the radius of the curvature. Got it? In our previous standards, we have learned rules for drawing ray diagrams for a spherical mirrors. One can obtain the position, size and nature of the image with the help of these diagrams. Similarly, we can obtain the image formed by lenses with the help of ray diagram. Now we will be learning images formed by a convex lens. The rules for obtaining images by a convex lens is: Rule number 1. If the incident ray is parallel to the principal axis, then the refracted ray passes through the principal focus. Rule number 2. If the incident ray is passing through the principal focus, then the refracted ray passes parallel to the principal axis. Rule number 3. A ray of light passing through the optical center passes through the optical center undeviated, that is, without changing its path. So these are the 3 rules for drawing for the images, found by a convex lens. Let us perform an activity. We need a convex lens, screen, meter scale, lens stand, candle. Now let's see the procedure. Draw a straight line along the center of the table using a meter scale. Place the lens on the stand at the center point O of the line. Now place a convex lens. Place the screen on one side of the lens. Move it along the line so as to get a clear image of a distant object. Now, after getting the clear image at this distance, mark its position. So this distance is known as the focal length. It is denoted by F. The focal length of the lens is 15 cm. Mark it as F1. Now mark another point to F1 and also measure the distance, and then again mark another point as F2 and to F2. Now children, place a burning candle on the other side of the lens far beyond 2f1. Place the screen on the opposite side of the lens and obtain a clear image of the candle by moving it forward or backward along the line. Note the position, size and nature of the image. So here the nature of the image is highly diminished, real and inverted, noted in the table. Now keep the candle at 2f2 and again move the screen to get a clear image. We get the position of the image between f2 and 2f2. The nature is diminished, real and inverted. Now place the candle at the 2f1 and again move the screen to get a clear and sharp image. We get the position of the image at 2f2. The size is same as that of an object and nature is real and inverted. Now position of the object is between f1 and 2f1. Move again the screen to get a clear image. We get the image position at beyond 2f2. The size of nature of the image is enlarged, real and inverted. Keep the object at the focus and then move the screen to get the clear image. So, what is happening here? The size of the image is very large. Now keep the object between F1 and O. Move the screen to get the clear image. What do we observe? Yes, we observe that image is not formed on the screen. However, it is the image or the position of the image is on the same side of the lens of the object and it is nature is magnified, virtual and erect. So children, these are the position of the object, position of the image, size of the image and nature of the image. So children, let us learn now. This is a convex lens MN with an optical center O and foci F1 and F2. An object AB is placed beyond the point 2F1. The incident ray BC starting from B and going parallel to the principal axis goes through the principal focus F2 after refraction along CT. The ray BO starting from B and passing through the optical center O of the lens goes along OS without changing its direction. It intersects CT in B'. This means that the image of B is formed at B'. As A is situated on the principal axis, its image will also be located along principal axis A' vertically above B'. Thus, A', B' will be the image of AB formed by the lenses. What do we understand from this? Yes, when an object is placed beyond 2F1, in front of the convex lens, then the image formed between f2 and 2f2. It is real, inverted, and smaller than that of the object. Now let us learn images formed by a concave lens. This is a concave lens. The rules for obtaining images by concave lens are: Rule number 1. When the incident ray is parallel to the principal axis of the concave lens, then the refracted ray, when extended backward, passes through the focus of the lens. Rule number 2. When the incident ray passes through the focus of the concave lens, then after refraction, the refracted ray becomes parallel to the principal axis. Rule number 3. When the incident ray passes through the optical center of the concave lens, then it passes without changing its direction. So these are the rules for obtaining images by a concave lens. This is a concave lens MN with optical center O. F1 and F2 are the foci. Now an object is drawn. PQ is placed between F1 and 2F1 in front of concave lens. The incident ray PA starting from P and going parallel to the principal axis goes along AD after refraction. If AD is extended backwards, it appears to come from F1. The incident ray PO starting from P and passing through O goes along the same direction after refraction. PO intersects the extended ray AF1 at P dash. That is, P dash is the image of P. As the point Q is on the principal axis, its image is formed along the axis at the point Q1, directly below P1. Thus, P1 Q1 is the image of PQ. The image formed by the concave lens is always virtual, erect, and smaller than the object. Are you understanding, children? Okay. Now, children, let's see the images formed by a concave lens. If the position of the object is at infinity, so the position of the image would be at first focus F1 and the size would be highly diminished, that is point size, and nature is virtual and erect. If the position of the object is at anywhere between optical center O and infinity, so the position of the image would be between the optical center O and focus F1. Size would be diminished and nature is virtual and erect. So these are the position of the object. So the image formed by concave lens is always smaller than the object, virtual and erect for all the position of the object. So children, I hope you all have understood the images formed by concave lens. Let us quickly summarize what we have learned today. Lens. A lens is a transparent refractive medium bounded by two curved surfaces which are generally spherical. So this is a lens. Convex and concave lens. This lens converges a straight beam of light and concave lens diverges a straight beam of light. Convex lens is thicker at the center and gets thinner as we move towards the edge, and concave lens is thinner at the center and gets thicker as we move towards the edges. Biconvex, plano-convex, plano-concave, concave, positive meniscus, negative meniscus. These are the different types of lenses. Okay, children? Let's move to the next. Rule number 1. Rules for drawing the ray diagram. Ray parallel to the principal axis will pass through focus. For convex lens, it passes through the focus on the right side, and concave lens passes through the focus on the left side. This is the rule number 1. Rule number 2. Ray passing through focus will become parallel to the principal axis in both the convex lens and also in the concave lens. So this is rule number 2 for drawing the images with the help of ray diagram. Next, rule number 3. Ray passing through optical center will emerge without deviation. That is, it will not change its direction for both convex and concave lens. So children, with this we have finished our today's session. I hope children, you all must have understood today's topic. In our next lecture, we shall begin with a new topic in the same lesson. Children, please do watch the video attentively and then read the lesson. Okay, children? Once again I say thank you for listening to me. Take care, children.